You're listening to EUAudio. Listen, learn, lead. Overcoming the barriers to smart materials. For all the benefits they offer, smart materials are not always a viable option for manufacturers. This is because they often rely on technologies that are still in their infancy or suffer from issues such as poor reliability and longevity. Whether it's shape memory alloys that respond to heat, piezoelectric materials that generate electricity when stressed, electroactive polymers that respond to electric fields, or any number of other smart materials, their benefits are clear. Smart materials offer manufacturers the ability to design products that are lighter and capable of responding to a variety of stimuli. They offer a way of reducing the number of components used in a product and can often be 3D printed into topologies that would otherwise be impossible using conventional manufacturing processes. However, for all the benefits they offer, smart materials are still not commonly used in industry. While materials such as shape memory polymers, SMPs, for example, have been made into shapes such as cantilevers, axial rods, linear springs or torsion springs, as well as more complex shapes including screw-like actuators, multi-fingered claws and foldable structures, they come with some weaknesses. Smart materials can be difficult to stabilise for repeatability. They can be slower and weaker than conventional actuators and sensors. Their performance can diminish over time, they may be difficult to control, and they can be expensive. In September 2017, Anders Diaz-Lantada, a professor at the Technical University of Madrid, had a paper published in the open-access journal Polymers, in which he explained that when choosing a family of smart materials, engineers must consider aspects such as the actuation force, the attainable displacements, the speed of response, and the bandwidth. He went on to explain that with typical actuation forces in the range of 1 to 100 N, and with common actuation speeds of 0.5 to 10 S cycle, shape memory polymers are not among the most powerful or rapid families of smart materials. As well as force and speed, when choosing a smart material, engineers must consider other characteristics such as creep, behaviour, stress, relaxation, fatigue, physical and chemical aging, and water absorption, among other things. Some of these issues are more easily fixed than others. Take speed, for example. A conventional actuator is made faster by applying a larger force to it, typically using a larger motor and a larger hydraulic or pneumatic pump. However, because an actuator made from a shape memory polymer doesn't require a motor or a pump, the material may itself need to be embedded with nickel nanoparticles, or something similar, to deliver a better heat-based activation process that is faster, more controllable, and more efficient. Not only does this highlight the need for engineers to carefully consider the material properties when choosing a smart material, it also reinforces the need to consider the complete life cycle of the part. As novel materials increasingly find their way into future designs, it will become vital that manufacturers can repair or replace parts at short notice. This is where working with a responsive parts supplier will become crucial and ensure that your supply chain doesn't become your weakest link. Despite the barriers, industry should embrace the benefits that smart materials offer and continue to innovate and push the boundaries of what's possible. EUAudio is brought to you by EU Automation.